Yep.
I'll run on memory. It's about 120 gig. So remember, only one clock. Only one clock. And the tool will not know which input is a clock. You have to tell the tool this is a clock. Okay? And then the tool will use it as a clock. If you make a mistake, then the tool will not know. But the tool will do the basic check for you. Do you have only one clock per flip-flop? Yes, you pass the check. Okay? Do you have rising edge? Yes, you pass the check. Do you have falling edge? Yes, you pass the check. Do you have rising edge and falling edge together? If you have, you didn't pass the clock check. Because you cannot have a flip-flop that will work on a rising edge and a falling edge. You can have two flip-flops, one is on rising edge, one is on falling edge. But not one flip-flop and both edges. Understand? So these are the basic things you have to know. And these are the checks the tool is going to do it for you. Okay? So if you make that mistake, then the tool will tell you you got an error in your code. Why? It's because these are the checks the tool will take care of. Okay? So how do we check if this input is a clock? By using the keyword rising edge. So this is a keyword. Opposite will be falling edge. Okay. So if you pass a check rising edge, that means this is a clock that will drive the flip-flop to respond on the rising edge. If you pass the falling edge, that means this flip-flop will work with falling edge only. You cannot have both on the same flip-flop. Understand? So far, any questions about rising edge and falling edge? So what can we do with this? We're going to look at the simplest possible sequential circuit that's as a clock, a flip-flop. It's a counter. Okay? We have dealt with counters in digital tool already, so you know what a counter is. So let's make one that's very simple. A counter is a sequential machine, a sequential circuit, because you will go through sequence of counts. Usually starting from 0 to 1 to 2 to 3 to 4 to 5, and then you keep going. When it maxes out the count, what happened to it?
It stops or resets.
Well, it doesn't stop. What happened to the counter when it maxes out the count?
Overflow?
No, it starts over again. No, it's not reset. It starts over. Okay? It's different from reset. Okay? So the counter will start counting, you max out, go back to the initial value, start doing this. Okay?
Oh, so it's just basically a loop.
No, loop it's a counting sequence. Okay? It's a counting sequence. So that's one type of counters we'll deal with. So let's make a very simple counter that is 3-bit binary up counter. We'll look at how does it behave. Now you think about this. A counter must have a clock input, otherwise it doesn't count. Okay? Usually there's a reset, so that you know where you start. Right? Counter should have some kind of output. If the 3-bit counter, that means you should have 3 bits output. A 3-bit counter should have 4-bit output, because there's nothing else to drive the extra bit. Understand? The counter must know what is the present count in order to figure out the next one. So from 4 to 5, 5 to 6, 6 to 7, 7 to 0, that's the sequence. If the counter cannot remember what's going on right now, you cannot figure out what's going to happen next. Okay? Understand? So we are going to create example number 5. Okay? When you're dealing with counters or any sequential circuits, we recommend you add 2 more libraries to this. Okay? Use IEE dot this is arithmetic. Okay? This is inside. So you're going to deal with negative number. Alright. So this is example entity. HDL example C5 is port. So we know what the clock usually is a CLK. We know we have a reset, which is IST. Usually it's active low because the push button is active low. You don't have to active low because of the push button behavior. Usually we define as active low. Okay. And then you have a Q, which is your count. This is a 3-bit counter. So we're going to use a vector, which is 2. Good. So 1 clock, reset, this is out. Okay, let's continue. This is architecture. Architecture. Is do a compile a project. You will compile. Let me see, right? 1, 2, 3, 4. You compile, but it doesn't give you any circuit because there's no architecture. So the syntax-wise, this is correct. So now we will fill the architecture. Right. So we look at a counter. Very easy. Suppose I write something like this. What does it say? It means whatever this value have plus 1 is going to the new value. So if A is equal to 1, A plus 1 is equal to 2, A becomes 2, 2 plus 1 becomes 3, 3 becomes 4. Okay, so this is the standard high-level programming incrementing. Okay? We cannot use the A plus plus. Okay, it doesn't work. It has to be A plus 1. Right. But how do I know it is 0, 0, 1? Not 0, 0, 0, 1. Why it has to be only 3 digits?
Probably because on the bus you told it to use 3.
That
2
is
down
correct.
to 0.
Because on the bus, you make it 3-bit. So when you do the addition, you should have 3 adding to 3, not 3 adding to 4, 3 adding to 10. Understand? All right. So next, this is our process. What should be inside the sensitivity list? What should change, cause this to change? What changes should make this counter behave?
Clock.
Clock is good. Anything else? What?
And the reset.
Reset. Reset is important. If you do this, This is wrong. Why? Why this is wrong?
Because that the Q underscore Z's value isn't determined by its value, it's determined by the other values.
That's not correct.
Output, not an input.
What do you mean?
Well, QZ like is out and the other two are in. Like in port, it says the first two are inputs and the other one's out.
That's not correct. Why this is wrong? The reason this is wrong is because QZ is an output, is write only. You cannot read it. If you cannot read it, how can we trigger your process? You cannot. Okay? It's a write only output. You cannot read it back. So you cannot put this in here. So reset if RST equals to 0. What happened to the output? The output QZ is going to be equal to, what value should we use here? If reset is active, what should be the output of the counter?
000.
000 is correct. Okay, reset your output. Next, else if rising edge of clock. Line code. So if rising edge of the clock, please add 1 to this. If there's no rising edge, nothing will happen. Okay? So as long as I have a rising edge of a clock, yes, it's going to be. So if you put in bell, it says begin. Oh, sorry, I missed the beginning. Begin, there's an end process.
Damn, I forgot I bought skills.
What?
Nothing.
Okay. Interface object QZ is mode out, cannot be read. What does it mean?
It means interface using
You don't need to repeat it back to me. What does it mean? Interface QZ is read. It's mode out, cannot be read.
Get my glasses out.
Says you have to change